So we are going to be working through 6I of the Unit 1 and 2 Methods Cambridge textbook. So we are focusing on learning to understand quartic and other polynomial functions. So with polynomials so far, we have mostly focused on cubic and understanding that relationship. But with quartic, or any even degree, we are going to be focusing on our graph that it looks more like a quadratic. So it's the same shape that what we have, but what you can see is it's a lot more flatter down here. So the same thing applies to what we know already, is the H and K helps us out with our translation, but it's our turning point. And also our A is what is going to be stretching or compressing. So that's our dilation. So pushing away from the x-axis or pushing towards the x-axis if it's compression. So I've got my graph here already that I've already graphed. So the first thing every single time that we need to be looking at this is our turning point. So here we've got x take away 3 to the power of 4 take away 2. If I make this 0, the x is 3, which means I'm left with -2. So that is always going to be our turning point, and that's the same when we did is quadratic. Likewise, finding x-intercepts is exactly the same. We are just going to make y equals 0, and then we're going to solve. So we get 2 to the other side, and then I'm looking at cubic root of 2 is equal to x minus 3, and then I plus 3. And that is a positive and negative, just to make sure when we're talking about that, because it's even. And then I'm labeling that. Now with this, I've labeled it in terms of assert, but I am also making sure that I'm putting it into the calculator to check the decimal so I can accurately graph it. Likewise, when I'm finding the y-intercepts by solving, first thing I'm going to do is make x equals to 0. And I'm just simply solving. -3 to the power of 4 equals 81. 81 take away 2 equals 79. Let's look at the next question. So the next question we have here is f(x) is equal to -2 x plus 2 to the power of 4 plus 1. So the first thing we look at is the turning point. The turning point is what's happening in my bracket here. To make that 0, x must be -2. So when that is 0, I'm left with that 1 here. So that gives me -2, 1. Find x-intercepts by solving. X-intercepts mean y equals 0. So I'll make y 0, and then I try and get x by itself. So I take away 1, I divide by -2, which gives me a half, and then I cube root a half. So final step is to get x by itself, so I take away 2. And that's my final answer. So the next step is to find y-intercepts by solving. So y-intercept is when x equals 0. So I make x equals 0. 0 plus 2 is 2. 2 to the power of 4. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. 16 times -2 out the front here is -32. -32 plus 1 is -31. So I've got all of my points that I need. I've got my y-intercept, I've got my turning point, and I've got both my x-intercepts that I am able to label. So other quartic functions that we have. So graphing a quartic function is similar to graphing cubic. Use the CAS calculator to help sketch accurately, because this is the hardest part. So be careful not to miss any key turning points or features on the graph. So for instance, with y equals 2x to the power of 4, take away 8x squared. If I was going to graph this and label it, I would need to know my 3 x-intercepts, and I would need to know my 2 local minimums. Let's look at this. Solving a quartic equation, 3x to the power of 4, take away 12x squared equals 0. So the first thing I can see here is they both have something in common. They both have 3x squared in common. So that is what I'll be factoring out. I'll be factoring out that, and that leaves me with x squared take away 4. So now that we've done this, the next part is we just need to solve. So to solve, each part needs to equal 0. So to make 3x squared equals 0, and I need to make x squared minus 4 equals 0. Well, this part here, x just has to be 0. On this side here, x squared must equal 4, and then I square root, and that gives me a positive and negative 2. So I've got x is equal to 2 or negative 2, and x is equal to 0. If I look at the next part where I've got 2x to the power of 4, take away 18x squared equals 0. Okay, so the first thing we are going to do with this question is we are going to factor and find the HCM. So for this question, we can see that they both have x squared and they have 2 that is a factor. So I'll factor the 2x squared out. That leaves me with 2x squared in brackets x squared minus 9 is equal to 0. So again here, I just need to solve. So because it's equal to 0, we're using null factor law. So 2x squared equals 0. So that just gives me x must be 0. X squared take away 9 equals 0. So I plus 9 to the other side. And then I square root. And that gives me positive and negative 3. And that gives me 3 values where x can be 0, 3, or negative 3. Another part we need to be thinking about is the axes of symmetry. So even functions is always going to be symmetric about the y-axis. So just be mindful of that. So I've got x to the power of 4 here, and I've got negative x to the power of 4. Okay, so another thing we need to be thinking about is odd degree polynomials. So odd degrees, if we think about this, what do we know is we can see that it has got an inflection at 0. But we just notice it's going to be quite flat to start off with as the power gets higher. And that's because if I have a half to the power of 5, if x is a half, it's going to get closer and closer to 0 because it's half times a half times a half times a half times a half. So be mindful of that. It's exactly the same shape when we're dealing with an odd function. So, state whether each of the following polynomials is even or odd. So, the first thing we need to be thinking about here, if it's even, then it's going to follow this rule. F of negative x is equal to f of x. Let's have a go. So, I put in negative x there. Negative x to the power of 6 is x to the power of 6. And then here I've got negative x squared. That becomes x squared. So is it the same? Yes, they are identical, which means the function is even. F of x is equal to x to the power of 5. Take away 2x to the power of 3 plus x. Again, I put in negative x into my equation. And what happens is that's going to be negative. This will be negative here. That means that's positive. And this here is negative. So I can grab the negative and take it onto the outside because negative and a negative is a positive. Negative and a negative is a positive here. And if I put a negative here, it turns back to being a positive. So I can do that, and it means that it is an odd function. So it's a very clear way of seeing that.